Hey everyone, had to put the GoPro on the charger for a minute, so there's a lot more done than the last time you saw. Well, we got both of our disconnects wired up now with, you can see they work. And that would be to isolate the inverter from the battery. And then I went ahead and put this switch up here. This will be a disconnect switch for the PV array when it goes in. And I went ahead and started running some of my PV wires. So I wanted to show you guys what I'm doing here at the end. I'm stripping these wires. And then I'm putting what's called a collet on the end of them. And what that does is it helps ensure a really good connection when you have a stranded wire rather than a solid copper wire. So I've got these little collets here, and I've got a special tool, and so that's all it is. Just a little piece of metal. It's going to slide right over our strands like so. And I've got this crimper tool. It's going to go right down on top. I'm going to make sure that flare is pushed all the way back up against the insulation, and then that's what it looks like. And I've done that with my PV inputs as well. So, like so. I strip that one a little bit long. So when I do that, when I have wires sticking out the end, is I go ahead, make my crimp, and just go back to my wire cutter at the end there and clean that up. So these guys here, just gonna run them right over to my disconnect like so, and Phillips head screwdriver, there we go. And so we're gonna go negative here, positive here. And the way these switches work is this input is controlled with that output, and then this one and that 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 one, and so forth. So actually, just to make this a little bit easier, what I'm going to do is I'm going to loosen these guys. Get the wrong size. I might have gotten the wrong size. Hold on a moment. Let's try the right size screwdriver. I'm going to loosen these guys up. So you can see I've got the collets already on all four. And so I don't know if you can see it, but you've got a number 1 here and a number 2 here. So when that switch goes, those, when the switch is closed, those are connected, and then this one is connected to that one to that one, and that one to that one. And what this will have is a little screw. It'll screw in right there to mount it to the inside. So it's a pretty nifty little thing, and it's spring loaded. And the reason why spring loaded is a good idea is it prevents arc flash. So it's a very quick disconnection, and like you're twisting it and you think you're actually about to break it, and then all of a sudden it's not active anymore. So let's see if we can get all these in here in one go, and then tighten them all down. Sometimes it's good to line them up and then push them in from the bottom. Let's see, this one might not be open all the way. Then when I get done with this, I actually need to go pick up some ground wire so that I can run the rest of the AC side. But I started running my main current carrying conductors on the AC side, and then realized that I didn't have any ground wire, so I have to go pick that up. So there we go. And like I said, those collets just give it a really nice connection that's strong, and it doesn't get flayed out like you normally do when you have a connection that's on stranded wire. Okay, I'm gonna line this guy up. There we go, like so. Give it some torque. And this is all output. I don't have any input. So when I run my PV array, I'll come in through the top here, and then you'll see I'll have the two that are coming in on this side into 1 and 3 will feed the PV2 input, and the two that are coming in on 5 and 7 and going out on 8 and 6 will feed PV1 input. So I'll have to keep that in mind when I'm wiring everything together. If there's any differences between the arrays, I'll make sure I account for that. But there you go. So that finishes the DC side over here. We still have the AC side to run. And then on the other inverter, we're not going to hook up anything for PV yet, because I think when I get this system up and going, I'm just going to have 2 strings. And so I'll just run everything through the MPPT on this one inverter. And then as we expand the system later on, we might utilize this if we need it. We'll see if we need it or not. You know, I like to oversize the systems when I can. But the reality is that with 2 arrays, and you know, this is capable of taking input of 4,000 watts on each side. So to put that in perspective, when we lived here full time, when we first went off grid, we had less than 2,000 watts of solar. So we're going to be living a high on the hog when we get this new system in. But anyways, with that being done, I'm going to clean some of this stuff up, put my cover on my switch, and then make a quick run to the hardware store to pick up what I need to finish the AC side. All right, guys, fast forward in time a little bit. We've got one of our AC runs done, so we can actually get 120 volts at the panel. So what I'm doing is I'm going to go ahead and put this on. I've already checked the torque on everything in here. So I'm going to go ahead and put this display panel back on. And when that's done, we will hook up a battery, and we'll go ahead and see about getting this bad boy commissioned. And then that'll allow us to work off of the house's AC system that's already in place while we do the other inverter and get that finished up. And then what we'll do is we will turn everything off, and we'll flip over and do our AC run on our other hot leg and tie the neutrals together and the grounds. And at that point, then we'll be able to commission this thing as a 240 split phase. But everything's gone really well. I should have put these communication cables on before I mounted these. That was a bit tough getting, so the places where the communication ports plug in are covered with this. And as you can imagine, getting to this one was very, very hard with that in the way. And so I would suggest anyone doing this that's going to be running this type of configuration, put those communication cables in before you mount anything below the inverter. So now I know. And let's see, got a couple more, put a couple in the sides here. And so what'll happen when this thing comes on is this is actually a LED status light, and you can program it according to the manual. It's got a couple different options for what it will do, what it will be on and represent. So that'll be a cool little thing to play around with. And then the other thing I'm going to be putting onto this system, well, there's 2 other things I'm going to be putting on this system. One will be a much smaller inverter that doesn't draw any electricity when it's on, or almost next to nothing. That will run our camera system and our Starlink system here. And the reason for that is I don't need all this energy to run those couple small loads that are probably combined 80 or 90 watts. So I have that small inverter, and in the evenings I can actually turn these off so that they're not self-absorbing. So when we go to bed, these won't be using power from the battery bank just to be ready for us to have a load overnight. The only thing that we'll really be using overnight would be the internet, the cameras, security lights, and things like that. Those are run off of that smaller inverter. And then I'm also going to mount a Raspberry Pi here because we're going to use a monitoring program called Solar Assistant. And I've got that copy. If we can get Starlink up and going tonight, we will go ahead and get that thing programmed and see what it can do. So there we go. Other than hooking these long cables to the batteries, this thing is ready to run. We've got our AC out. We got our PV in. Again, that's not doing anything. We've got our safety switch, our breaker for the battery supply. We've got our bus bars wired up and ready to go. What I'll probably do once I get this over here run is I'll go ahead and tighten everything up and get that ready to go. And then tomorrow I'll do the final commissioning and get this thing set up on split phase.